In this video, we'll cover the SLI types we generally recommend using to track the reliability of a request-response interaction in a user journey. These are availability, latency, and quality. We'll also talk about other situations where these SLI types might be useful. The availability of a system serving interactive requests from its users is a critical reliability measure. If your system is not responding to requests successfully, it's safe to assume it is not meeting your users' expectations of its reliability. The suggested specification for request response availability SLI is the proportion of valid requests served successfully. Turning this specification into an implementation requires making two choices. Which of the requests this system serves are valid for the SLI, and what makes response successful? The definition of success tends to vary widely depending on the role of the system and the choice of how to measure availability. When considering the availability of an entire user journey, care must be taken to enumerate and measure the ways that users can voluntarily exit the journey before completion. Availability is a useful measurement concept for a wide range of scenarios beyond serving requests. The availability of a virtual machine could be defined as the proportion of minutes that it was booted and accessible via SSH, for example. Sometimes complex logic is required to determine whether a system is functioning as a user would expect it. A reasonable strategy here is to write the complex logic as code and export a Boolean available measure to your SLO monitoring system. You can then define a similar SLI to the virtual machine example we just gave, based on the proportion of minutes the system was available. The latency of a system serving interactive requests from users is an important reliability measure. A system is not perceived as interactive by its users if the requests are not responded to in a timely fashion. The suggested specification for a request response latency SLI is the proportion of valid requests served faster than a threshold. Turning the specification into an implementation requires making two choices. Which of the requests this system serves are valid for the SLI, and when the timer for measuring latency starts and stops. Setting a threshold for fast enough is dependent on how accurately measured latency translates to the user experience and is more closely related to the SLO target. Systems can be engineered to prioritize the perception of speed via techniques like prefetching or caching. Requests may be made in the background by applications and thus have no user waiting for the response. It's common to set your sights on the long tail with a 95% or 99% target when setting a single latency threshold, where your SLO is effectively saying most requests must be responded to faster than this for our users to be happy. But it's quite likely that your users would be happier if your SLOs covered more than one point in the latency distribution, because the relationship between latency and user happiness tends to be an S-curve rather than linear. Setting other thresholds that target latency for 75 to 90% of requests can help describe this S-curve in a more nuanced manner. Targeting fewer than 75% of requests weakens the promise you're making to your users, so you should only do this with good reason, like if you have a cache in front of your service that results in a bimodal distribution of response latencies. Latency can be equally important to track for data processing or asynchronous work queue tasks. If you have a batch processing pipeline that runs daily, that pipeline probably shouldn't take more than a day to complete. Users care more about the time it takes to complete a task they queued than the latency of the synchronous queue acknowledgement. One thing to be careful of here is only reporting the latency of long-running operations on their eventual success or failure. If the threshold for operation latency is 30 minutes, but the latency is only reported when it fails after 2 hours, there is a 90-minute window where the operation was missing expectations, but not measurably so. If your system has mechanisms to trade off quality of the response returned to the user with something else, such as CPU or memory utilization, you should track this graceful degradation of service with a quality SLI. Users may not be consciously aware of the degradation in quality until it becomes severe, but their subconscious perceptions may still have an impact on your business if, for example, degrading quality means serving less relevant ads to users, reducing click-through rates. The suggested specification for a request response quality SLI is the proportion of valid requests served without degrading quality. Turning this specification into an implementation requires making two choices: which of the requests the system serves are valid for the SLI, and how to determine whether the response was served with degraded quality. In most cases, the mechanism used by the system to degrade response quality should also be able to mark responses as degraded or increment metrics to count them. It is therefore much easier to express this SLI in terms of bad events rather than good events. Similar to measuring latency, if the quality degradation falls along a spectrum, it can be useful to set the SLO targets at more than one point from that spectrum. For a somewhat contrived example of this, consider a service that fans out incoming requests to 10 optional backends, each with 99.9% availability target and the ability to reject requests when they are overloaded. You might choose to specify that 99% of the service responses must be served with no missing backend responses, and 99.9% must be served with no more than one missing response.